Red on yellow, kill a fellow. Red on black, friend of Jack. This rhyme is used to identify the phenotypic signals presented on the noxious or venomous coral snake, the red on yellow model, compared to its harmless mimic, the red on black milk snake. The colloquial rhyme has evolved in tandem with understanding the convergent evolution of the mimic, the milk snake, developed to resemble its model to evade predation. The Red on Black poem is a false narrative of Batesian mimicry. It underscores the regional variation and analogs of mimics to their models. What if a mimic is without a model? This phenomenon is known as allopatry, where a mimic appears in areas uninhabited by their model. In contrast, sympatry, a proponent of Batesian mimicry, regards populations where mimics appear in areas inhabited alongside their model. Today, we will be discussing the different evolutionary explanations of mimicry and aposematism, and the experimental consequences of Batesian mimics without models. Species that develop obnoxious phenotypic indicators as a defense mechanism against predators employ aposematism, otherwise known as warning coloration. Noxious species advertise using visual cues to other organisms of their toxicity through displays of bright colors or distinctive patterns. The evolutionary explanations of aposematic mechanisms explain sympatric mimic model complexes, including Darwinian, Mullerian, Batesian, and Wallacean theories. Starting with Charles Darwin, the father of evolution, the coevolutionary theory of mimic model complexes is evaluated by natural selection. As Darwin explained, natural selection is descent with modification, where a species population evolves resulting in heritable traits over time. As there are multiple types of mimicry, discussing the different complexes mimics and models may implement is essential. Mullerian mimicry describes complexes where the mimic and its model species are noxious to potential predators. Probably the most famous example of Mullerian mimicry are bees and wasps. Both species have yellow and black coloration as indicators of the threat of their stingers. The two species mutually benefit from having shared warning signals, as potential predators will only have to learn one phenotypic signal to avoid two distinct species. Mullerian mimics have honest signals. These mimics are equally as noxious as their model. Mullerian mimicry is a direct contrast of Batesian mimicry. As the mimic model complex for Mullerian mimicry involves honest signals, Batesian model mimics are dishonest. Batesian mimics utilize shared characteristics as a survival strategy to avoid predation. Henry Walter Bates published an empirical evidence supporting Darwinian natural selection of mimic model complexes, now known as Batesian mimicry. Batesian mimics involve a noxious model with a harmless mimic. The mimic is defenseless and co-evolves to resemble the dangerous modeled aposematic signals. The protection the mimic develops is dishonest, relying on negative experiences learned by predators to avoid the model. Bates investigated several species of butterflies, where he noted that some of his butterflies displayed mimicry. Using selective advantages, harmless insects utilize protective adaptations in which one species assumed the coloration of another to escape, and as Bates said, the persecution by insect enemies from which the other is set free. Batesian mimicry was re-evaluated by A.F. Wallace, who defined laws associated with mimic model complexes. Wallacean mimicry, a subset of Batesian mimicry, must meet these requirements: that the mimic and its models inhabit the same geographic area, are abundant, and have a defensive mechanism. Mimics are less plentiful and have no real protection other than aposematic signals. Experiments cannot be replicated in higher order populations, as evolutional time encompasses generations across generations. Learned behavior to avoid aposematic signals is a form of interspecific communication. The model species for the mimic will be the scarlet king snake, the Lampropeltis ellipsoides, with the venomous model being the eastern coral snake, Mimicry fulvus. Both display aposematic warnings coloration of red and black stripes following the length of their bodies. The characteristics defined in the colloquial poem Red on Black, Friend of Jack, Red on Yellow, Kill a Fellow are accurate, as the coral snake has an additional yellow stripe, while the king snake has an alternative white stripe. The mimic model snake complex of M. fulvus and L. ellipsoides are found in the southeastern United States, specifically the Carolinas. M. fulvus is found exclusively in southern Carolina, with its mimic dispersed in North and South Carolina. These will be the underlying geographical locations of note for allopatric or sympatric snake species. The evolution of biological systems in sympatric if the mimic model complex population occupy the same geographic range during the same time interval. The mimic species co-evolved parallel to its model, acting directly dependent on its model. In contrast, in allopatric speciation, the mimic model species occupy different geographic ranges during the same time interval. The mimic species is independent of the model species, as they are reproductively isolated and occur in ecological niches without presence of the model species. Elelapsoids are found in the Sandhills region of North Carolina and can occur in both sympatry and allopatry of its mimic. Those that occur in allopatry, such as populations from North Carolina, are more indicative of M. fulvius than sympatric Elelapsoids. This phenomenon reflects divergent evolution and predator-mediated natural selection of Elelapsoids in sympatry versus allopatry. Batesian and Wallacean mimicry can be experimented using replicas of various snake phenotypes. The experiment I will be referring to is incorporated with wire and color-coordinated polymer clay to indicate the phenotypic cues for specific snakes. The experiment involved variant phenotypes of mimic and model replicas. One replica resembled the sympatric phenotype, consistent with average patterns of the non-venomous Elelapsoid snake. Another replica presented hybrid phenotype with both allopatric and sympatric patterns. The last replica presented with an allopatric phenotype of the non-venomous Elelapsoid snake. The relaxed selection hypothesis attempts to explain how the selection against imperfect mimics occurs when their cost of attacking a model is high relative to the benefit of consuming the mimic. The selection of imperfect mimics are relaxed, allowing mimics to be more imperfect for a given level of fitness. Mimic model complexes are assumed to demonstrate convergent evolution, where unrelated species such as the coral snake and the king snake independently develop traits through similar environmental pressures. However, immigrant isolation and local adaptations align with divergent evolution. Convergent and divergent evolution may counter each other, but there is some overlap between them. Batesian mimics can occur allopatrically, resulting from selection, gene flow, and ecological range. Divergent evolution contributes to speciation from the encouragement of early-stage reproductive isolation, local adaptation of conspicuous phenotypes in sympatry, where mimic phenotypes predominate, and allopatry, where non-mimetic phenotypes predominate, immigrants between selective settings, and any hybrids that emerge across environments should disfavor divergent evolution. Divergent evolution is accompanied by predator-mediated natural selection. The disfavoring of phenotypes forms the basis of pre- and post-mating isolation. This phenomenon is immigrant isolation, described as when immigrants in a new geographical area experience lower fitness rates compared to native counterparts. As Batesian mimicry promotes pre- and post-mating isolation in snakes' mimicry complex revealed, only in populations of symmetry did selection favor precise mimicry, with hybrid phenotypes being disfavored. Allopatric individuals display more red and less black phenotypes in their patterning than sympatric individuals. This is the fostering of local adaptation. Many mimics defy the assumption that they should only appear in symmetry or in areas where their model is present by occurring in allopatric regions where their model is absent. In allopatric areas, the population of mimics should be particularly vulnerable to reproductive isolation since they are subjected to conflicting selective pressures. It has been quantitatively proven that Batesian mimics promote early reproductive isolation. Today we reviewed different methods of adaptation of conspicuous coloration or aposematism before discussing differing evolutionary theories. Still, the mimic and its model do not always display the same ideals that Bates and Wallace presented, where the mimic and model occur in sympatry. While Bates' thesis is accurate for his butterflies, it is not for other mimic model complexes. The colloquial poem is accurate, but not the ensuing Batesian mimicry lesson. A secondary conclusion is drawn in this presentation, where mimics have significant drawbacks, including immigrant isolation and pre-mating reproductive isolation.